Nice to see you again. In this and the next video, we are moving to section 3, the metric notation. What is the metric notation? Well, let's answer this question by looking at what the metric system is. A metric system is a system of measurement based on the power of 10. We had learned the power of numbers in the previous video. By based on the power of 10, we mean that we measure by 10, 10 squared, 10 cubed, and so on. They correspond to the units digit, the tens digit, the hundreds digit, etc. of a number. This will be clear when we go on. The number notation of the metric system is called the metric notation. This is the content of session 3 in this video and the next video. Session 3 will cover two topics. Session 3.1, the scientific notation, and Session 3.2, the metric prefix. If these terms look unfamiliar to you, don't be panicked. It's a good opportunity to learn something new. They are actually quite simple and will be clear in these two videos. Let's start with Session 3.1 now, the scientific notation. In this subsession, we will talk about the scale of numbers, such as 100, 1,000, million, and so on, and the scientific notation to express numbers in terms of powers of 10. Let's start with the scale of numbers. Do you know how far is the Sun away from the Earth? It's 1,496,000,000 kilometers away. This is a large number. How many digits are there in this number? Can you tell it in 1 second? Normal people cannot. But how about expressing the number this way? Can you tell how many digits are there in 1 second? In order to make it easier to read a number, we usually separate every 3 digits in the integer part of a number by a comma. It's much easier to recognize that there are 9 digits in this example, right? Actually, for the number of 4 or more digits, not only the number is separated into groups of 3 digits by commas, but also each 3-digit group is counted by different units. We will see the details in the following. This slide shows that numbers of 4 to 6 digits are counted by thousand. 4-digit numbers start from 1,000, then 5-digit numbers from 10,000, and 6-digit numbers from 100,000 to 999,999. Numbers of 7 to 9 digits are counted by million, from 1 million to 10 million to 100 million up to 999,999,999. Numbers of 9 to 12 digits are counted by billion, from 1 billion to 10 billion to 100 billion up to 999,999,999,999. Numbers of 13 to 15 digits are counted by trillion, from 1 trillion to 10 trillion to 100 trillion up to 999 trillion, 999 billion, 999,999,999. This is already a very, very large number. But how about even larger numbers? We seldom use numbers as large as this. So, we only use some particular terms to symbolize particularly large numbers. We call numbers as large as 10 to the power of 100 googol. How large is this number? Well, it is 1 followed by 100 zeros. Very large indeed. Moreover, does the pronunciation of Google sound familiar to you? Yes, you are right. This is where the name of the search engine Google derives from. It just wants to signify how many things you can find in their search engine. For even larger numbers, as large as 10 to the power of 10 to the power of 100, we can call them Googleplex. These are extremely large, so large that they become countless. Having finished the topic of the scale of numbers, in this slide, I would like to tell you some trivia about numbers. For numbers with integer and decimal parts, like this one, we write it as 1,234,567.89. You see this kind of notation in Taiwan, Japan, USA, and UK. But if you travel to some countries like Germany and Indonesia, you will see the same number being written as 1.234.567,89. They are just two different notation systems for the same number. So, next time you see such an expression, you will not be confused. Finally, we would like to give you some questions to practice for the scale of numbers. There are 3 numbers in this slide. Do you know what these numbers describe? Well, the first one is the area of Taiwan in kilometers squared. The second number is the population size of Taiwan, the number of people. The third number is the population size of China. Can you read these numbers? In the following, we are going to turn to the scientific notation. In order to understand the scientific notation, let's try to answer 2 questions. The first question is, how many galaxies are there in the universe? According to the estimation of NASA in October of 2016, there are about 2 trillion galaxies. This is a huge number. There are 12 zeros following the first digit 2. it is so huge that it's not easy to get the idea of how many zeros are there at the first glance. To assist our quick perception of such a huge number, the scientific notation comes into play. The number 2 trillion can be written into 2 times 10 to the power of 12. From this expression, one can easily see that there are 12 zeros following 2 because of the factor 10 to the 12th power. That makes our life easier, isn't it? The second question is, what is the radius of a hydrogen atom? The answer is 0.00000000053 meters. This is a very, very small number. There are so many zeros after decimal point that you cannot even remember how many zeros you had read after counting a few. But if it is written in a scientific notation, this number becomes 5.3 times 10 to the power of minus 11. This means that the digit 5 is in the 11th digit after the decimal point. This is much more straightforward to get the idea how small this number is, right? So, what is the scientific notation? It is to write the numbers into powers of 10. For example, the number 36,000 can be written into 3.6 times 10 to the power of 4. This is the scientific notation of 36,000. In this example, the key factor is 10 to the 4th power. It is composed of two elements, the base 10 and the exponent 4. Let's look at how the scientific notation works for large numbers. Let's start from 1. 1 equals to 10 to the 0th power. 10 to the first power is 10. 100 is written into 10 squared. Next, we have 10 cubed for 1,000, 10 to 4th power for 10,000, and then to the 5th power for 100,000. How does this work? For 1,000, there are 3 zeros after 1. So it is 10 to the power of 3, or 10 cubed. For 10,000, there are 4 zeros after 1, so it's 10 to the power of 4. For 100,000, there are 5 zeros after 1, so it's 10 to the power of 5. Similar rules apply to larger numbers. So 1 million equals to 10 to the 6th power. 10 million is 10 to the 7th power, and 100 million can be written into 10 to the 8th power. Further, 1 billion is 10 to the power of 9. 10 billion equals to 10 to the power of 10. And 100 billion can be written into 10 to the power of 11. And 1 trillion is 10 to the 12th power. 10 trillion is 10 to the 13th power. 100 trillion is 10 to the 14th power. Until Google and Googleplex. Next, we look at the scientific notation for small numbers. If we start from 1 and going in the direction of even smaller numbers, we first run into 10 to the power of minus 1, which is 0.1. Then we have 0.01 as 10 to the power of minus 2, and 0.001 as 10 to the power of minus 3. Going even smaller, we have 10 to the power of minus 4, minus 5, and minus 6. How does the notation work for small numbers? For 0.0001, we have 3 zeros after the decimal point, and 1 is in the 4th digit. So, we get 10 to the power of minus 4. For 0.00001, 1 is in the 5th digit after the decimal point. So, we have 10 to the power of minus 5. Similarly, 1 is sitting in the 6th digit after the decimal point for 0.000001. So it is written into 10 to the power of minus 6. Here, some more examples of writing numbers into scientific notations. The number 23,600,000 can be decomposed into 2.36 times 10 million, which equals to 2.36 times 10 to the 7th power. Similarly, 1,380,000,000 can be expressed by 1.38 times 10 to the 9th power, and 0.000025 is 2.5 times 10 to the power of minus 6. The last slide of this topic is a question for you to practice. Can you express these two numbers in scientific notation? We finally finished the subsection of scientific notation. In the next video, we're going to talk about the metric prefix. See you soon.